We're going to look at a story problem that involves compound interest. One of the first things that we need to decide is whether this is going to be continuous compound interest or not continuous. In the statement here we have quarterly, so this is not going to be continuous, so we're not going to be using the number e. So the general formula for compound interest is this. Being that we're asked for quarterly instead of annual compound interest, we're going to have to modify this formula because we're not going to be doing this once per year. We end up getting multiple times per year, so we're going to multiply something by this time period here, and we're going to essentially spread out that interest rate, so we're going to divide this. So our modified formula will be very similar, but with an extra term in it. We're going to add an n variable to this. We're going to divide the r, which represents our rate, and we're going to multiply our t, which represents time in years. So this is our modified formula that we're going to use. So the p is representing principal. This is the amount we're investing. The r is the rate, that's 6%. When we put this in, we're going to have to use a decimal, not a percent. The n is going to represent how many times each year that we are going to do our compounding. Since we are doing quarterly, that's going to be 4 times per year, so we're dividing by 4 here and multiplying by 4 here. And the contract that is mentioned in our story problem is 7 years, so t is going to be 7. Alright, so substituting all of that in, we have $5,931.89 times, in parentheses, 1 plus 600ths divided by 4 to the 4 times 7 power. And then we can simplify some things in here. We need to make sure that we are following the order of operations here. That is extremely important. One of the first things that I'm going to do is I'm going to, in the parentheses, do the division and then the addition. In the exponent position, there's only multiplication here, so I'm going to do that also. So those are the simplifications we're doing using order of operations. I have simplified in the parentheses and I've simplified my exponent. So now order of operations, I'm going to do this exponent next. So this is going to give me approximately 1.51722218. And I'm going to multiply this number by this number to get that final product, which will be what we should be receiving in our bank account at the end of that 7 years. Alright, so since this is money, we're going to have to round this. And depending on the method that you use for rounding, you're going to have to determine how you're going to do this. In this case, we're going to give the customer the benefit of the fraction of a penny, and we're going to round this up to the next highest penny. And so our customer from the story problem is going to have $9,000 in their bank account at the end of that 7 years. And so this customer is making over $3,000 on this investment in a 7-year time period. Hopefully this has been helpful to get a look at a story problem and dealing with compound interest and deciding which formula to use, why we're using it, and to get the kind of answer that we would expect from this story problem. Cheerful calculating.